For this last video, for lesson 8.1, we're going to look at two examples further dealing with composition of functions. The next example we're going to look at asks us to determine if a function composition, if it's commutative. Well, let's go back and let's define commutative to begin with. Remember, the commutative property for addition says that if I have 2 plus 3, that's the same as 3 plus 2. The commutative property for multiplication, it also works there because 2 times 3, which is 6, is going to give you the same value as if you take 3 times 2. If you notice, what this is dealing with is the order. The commutative property deals with the order of doing things. Does the order matter? With addition and multiplication, it doesn't, because 2 plus 3 is 5. 3 plus 2 is also 5. Or 2 times 3 is 6, and 3 times 2 is also 6. The commutative property does not work with division. 2 divided by, well, let's do this, make it a little easier. 8 divided by 4 is not the same as 4 divided by 8. What we want to see is the commutative property, does it work for composition of functions? In other words, does f following g of x, does that equal the same as g following f of x? And if you watch the first video, you notice that we already solved this. But let's look at these examples. It says f of x equals x minus 2 and g of x equals 3x squared. They first asked me to find f following g of x. In other words, remember too, if you don't like this symbol, just put that second item in parentheses. So what we're going to do here is we're going to take g of x and put it inside of function f. G of x is 3x squared. I'm going to put that over here in for x. When I do that, I get, so let's see, f following g of x ends up becoming 3x squared minus 2. Remember, we're just replacing this x with a 3x squared. We're not multiplying them together. Don't make that mistake. This isn't like the distributive property or anything. You're substituting this 3x squared in for x. So it's 3x squared minus 2. There's nothing more I need to simplify there. That's my answer. Let's see if I get the same thing now when I take g following f of x. Or again, what I'm going to do is I'm going to take function f and put it inside of function g. So function f is x minus 2. I'm going to put that in there for function g. So I'm replacing the x with x minus 2. Be very careful with this one. Because it's 3 times whatever x is squared. Well, it's no longer an x, it's x minus 2. It's that whole quantity. We need to square it. Well, remember, we talked about the binomial square theorem. We have to square this first, so this is going to become, when I use the binomial square theorem, I square the x, I get x squared. The shortcut is I take and multiply these two items together. X times negative 2 is negative 2x. And double that, so that becomes minus 4x. And then I square the negative 2, that gives me a positive 4. It's much easier than trying to take x minus 2 times x minus 2, which you could do that and FOIL it. You get the same answer, it just takes more time. Now to get our final answer, I'm going to distribute the 3 through. So it becomes 3x squared minus 12x plus 12. So g following f of x is 3x squared minus 12x plus 12, where f following g of x, using the same two functions, just in a different order, gave me 3x minus 2. So in other words, they're not commutative. So demonstrating that with just one example proves that no matter what functions we use, the function of function composition is not going to be commutative. Now granted, I suppose there might be a couple here or there that might end up working, but overall, just know that composition of functions is not commutative. So if you want to do this example, just to have more practice, you can, but it's going to prove the same thing. But as far as having practice with x's instead of having numbers involved, if you want to practice those, you can. Which you might want to pause the video. I'll just go ahead and give you the answers now. For the first one, f following g of x ends up giving you 2x squared plus 5. If you did the work for this one, you end up getting 2x squared plus 20x plus 50 as your final answer. Okay, but let's look at this last example. This is where it gets kind of tricky. It says, let x be a real number. Let s of x equal 1 over x squared, that's an x there, and let function f be given by f of x equals x squared minus 64. What is the domain of s following f? Now remember, domain refers to what values can we put into that function. Sometimes we have to restrict the domain, or say that there's a certain things that we can't put in for x. Well, if I look at x squared minus 64, any real number would work. Okay, I can square any number. I can do negative numbers, positive numbers, fractions, decimals. I can square anything and subtract 64 without having any issues. So all real numbers would work in the domain for that function f. Function s, however, is a little bit unique. I have 1 over x squared. Think for a second. What is the one number we can't divide by? Well, you should have thought of 0. We can't divide by 0. I can never divide by 0. So what that means is that x can't be 0. I can't input it into x. So going back over here, remember what we're going to end up doing is we're going to put f inside of function s. We're going to put that answer inside of function s. So the one number that this can't equal is 0. So I want to figure out what x would have to be to give me 0 as my answer, because I can't have that as part of my domain. So let's solve this. If I add 64 to both sides, I get x squared can't equal 64. Now what two numbers would I square to give me 64? Well, if you said 8, you're only half right, because negative 8 would also not work, because negative 8, when I square that, also gives me 64. So in other words, the domain is going to be all real numbers except 8 and negative 8. Because if you think about why, well, let's just try the 8 for a second real quickly. If I put 8 in the function f, 8 squared is 64. 64 minus 64 is 0, and I can't put 0 in for x. Okay, why don't you guys try this next one on your own? So pause the video and then play the video when you're finished to check your answer. Okay, so let's see how you did. So this is saying s of x is again 1 divided by x, and function f is x squared minus 100. What is the domain of s following f? Well, again, I can put anything in here for x as it is, but when I go over here to function s, x can't be 0. So that means that when I set this up, x squared minus 100, the value of that can't equal 0. So now what I'm going to have to do is I'm going to have to solve this equation. So I add 100 to both sides. And what two numbers, when I square them, would give me 100? Well, that would be 10 and negative 10. So your answer for this one should have been, your domain is going to be all real numbers except 10 and negative 10. Okay. That's it. So hopefully you have a better understanding of composition of functions.